Audio Jungle.
Welcome to Maths TV. This is step-by-step revision series, and we are going through direct and inverse proportion or direct and inverse variation. This is part 2 of this topic. If you have not watched part 1, better to go through that video as well, and then after watching that one you can go through this topic part 2. In part 1 we have gone through this direct variation in detail and graphs also. Now in this topic, in this part 2, we will be going through inverse proportion, or it is also known as inverse variation. If two quantities are inversely proportional, the product of the two quantities is constant. Inverse proportion can be written as a proportionality statement. For example, y is equal to 1 over x, which is read as y is inversely proportional to x, or y varies inversely as x. So in questions they are giving different wordings like y is inversely proportional to x, or sometimes they are giving y varies inversely as x. As with direct proportion, we can rewrite this as an equation using a constant of proportionality. So inverse variation is having graphs like this. Now I will explain on the paper. When it is given y is indirectly proportional to x, we are writing y is inversely proportional to x like this, and we can write in proportionality sign into equality sign, and we can write y is equal to 1 k into 1 over x like this. So k will be equal to k is equal to y into x. So this is the equation, this is the constant which is the product of x and y, we can mention in this format. Now we will be choosing some questions, and selected questions we'll go through so that we can understand better this topic. This is question number 1 which we have selected for practice. Copy and complete the table below if y is proportional to 1 over x. So given is y is proportional to 1 over x, which implies y is equal to k over x. So constant k we have utilized. Now in this table, for this 5 and 12, these are the two values which are given for x and y. We can utilize these two values to find the value of k. So y value is 12. We can write 12 is equal to k over x, which is 5. So in this equation we have replaced these two values. So this implies k is equal to 12 into 5, which is equal to 60. So value of k is 60, which we will replace in this equation, and we will get y is equal to 60 over x. This will be our equation. Now we can use this value and find y, value of y. So when x is equal to, at x is equal to 2, we will be using this, y will be equal to 60 over 2, 60 over x value we have replaced. So this will be equal to 30, and this value 30 we can replace here, y value as 30. Now next is x is equal to 6. So at x is equal to 6, we can replace in the same equation y is equal to 60 over 6, which is equal to 10, and we can write in this table value of y will be equal to 10. Next we have to find value of x when y is given and y is equal to 4. So in the same equation we can write at y is equal to 4. So 4 is equal to 60 over x, and this implies x will be equal to 60 over 4. We have shifted x to this side and 4 to this side, and this will be equal to 4 1s are 4 and 4 5s are 20, so it will be 15. So x is equal to 15. In the table we will fill the value, and this will be 15. Now next value, y is equal to 3, so we will be taking y is equal to 3. So at y is equal to 3, we can write 3 is equal to 60 over x. This implies x will be equal to 60 over 3, which is equal to 20. So x will be equal to 20 in this case. So this is indirect variation question which we have done. Hopefully you understood this question. Now we can move to question number 2. And question number 2 says the wavelength of sound waves is inversely proportional to their frequency. So wavelength we can represent by lambda. So lambda is equal to is proportional to, basically proportional to frequency. So we can write 1 over f, frequency. So lambda will be equal to k into 1 over f. So this will be our equation. Find the frequency. This is when the wavelength is this one, frequency is given this. Find the frequency when the wavelength is this. So these two values we will use to find the value of k. Wavelength is 0.25 when frequency is 1360. So k will be this one 1, and f value will be 1 over 1360. Now we can shift this to the side. 0.25 multiplied by 1360 will be equal to k, and now we can use calculator to find this. 0.25 multiplied by 1360, this will be equal to 340. So value of k which we got is 340, and this value we can replace in this equation. Lambda is equal to 340 over f. Now this is our equation which we can use to find frequency in A part and wavelength in B part. So A part, find the frequency when the wavelength is 0.8 meters. 0.8 meters frequency is given. So now we can use lambda is equal to 340 over f, and f is 0.8 frequency we have to find, and wavelength is 0.8. So we can write 0.8 is equal to 340 over f. This implies f will be equal to 340 over 0.8, and 340 over 0.8 will be 0.8. This one will be equal to 425. So this will be 425. This will be hertz. So H capital, Z small. So this will be hertz. Now B part. In B part, they're saying find the wavelength. Find the wavelength when frequency is this one. So frequency is given. Now again our equation is lambda is equal to 340 over f, and frequency is given, so we can replace here 340 over 850. So this will be equal to 340 divided by 850. So this will be equal to 0.4. So value of lambda will be 0.4 meters. So this is done. Hopefully you understood this question as well. Now this is question number 3. The force exerted by a magnet on a metal sphere is inversely proportional to the distance between them. So force F is inversely proportional to the distance between them. So 1 over d, this is how we can write. and this implies equation we can express the force F exerted by the magnet in terms of x. Okay, F force and distance, they have taken x, so instead of d I will replace here x, so that we same variable we want to use. So this will be x as distance, so between the magnet and the sphere. So this will be, when we use constant of proportionality, F will be equal to k over x. So this will be the equation, which is a part. Basically they are asking us to express this equation. Now for this one, when distance, they are giving us, when distance between them is 20 centimeter, force exerted by the magnet is this one. So we can replace this. F will be 0.5 Newton. This F will be equal to k over x, and x value is 20 centimeters. So I will write here 20, and this implies k is equal to 0.5 into 20, and 0.5 multiplied by 0.5 multiplied by 20, this is resulting to 10. So k value will be 10. Now our equation, this equation will become F is equal to 10 over x. This is the final equation which is required for part A. Now in part B, find the force we have to find when the magnet is 10 centimeter from the sphere. So same equation we'll be using for part B. F is equal to 10 over x, and they're saying force we have to find, F we have to find when the magnet is 10 centimeter. So distance is 10 centimeter, so 10 divided by 10 will be 1. So 1 Newton will be the force. This is answer for part B. Answer for part C also, we can go through part C. How far is the magnet? So now we have to find the distance from the sphere when force is 20 Newton. So force is given as 20 Newton. So same equation we will be using. F is equal to 10 over x. Now 20 Newton force and 10 over x. This implies x is equal to 10 over 20. This is equal to 1 by 2 or 0.5. This will be in centimeters, because units mentioned in the question are centimeters. So this will be our answer. Hopefully you understood these selected questions. There are some other types of inverse variations also. Sometimes they are mentioning like if A is inversely proportional to the square of U. If it is square of U, we can write A is inversely proportional to U square. So in that case we will be taking square, and constant of proportionality again we will be taking k. Our equation will become A is equal to k over U square, and this equation we will be using in that case. Now sometimes they are saying if A is inversely proportional to the cube of U, we will write A is inversely proportional to 1 over U cube, or we can write A is equal to k over U cube. So this is how we are using in case of square and cube. And root square also, if h is inversely proportional to the square root of g, then h is directly proportional to 1 over square root of g. Roots we are taking, so h is equal to k over g under root. So this is how we are taking in case of root also. So these are other cases which similarly we are solving, but while writing equation we'll have to be careful for that. And if we see the indirect proportion graphs, as we know that indirect variation, one value is increasing when the other value is decreasing. So if we plot that graph, if you see this one, when x side is increasing, y side is decreasing. When y is increasing, x side is decreasing. So this type of graphs are indications that this is having inverse proportion. So in table also we can see the speed is decreasing, like 100, 60, 50, 40, 30, it's decreasing, whereas time is increasing, 3, 5, 6. So one value is increasing while the other one is decreasing. So this is all about for this part. You can go through practice questions as well, and don't forget to subscribe the channel Maths TV, and also like the video as well, and introduce this channel to your friends and also to your respected teachers. Thank you very much for watching. Take care. Bye.